Gokunath from Crack with Gokunath YouTube channel. Today we are going to see integral calculus. Integral calculus is one of the important chapter in both physics and mathematics. On talking about integral calculus means sum of all the values. Sum of all the values means the summation, the summative process. The summation only called as sum of all the values. Integral calculus means the summation, the most important thing. Integral calculus means summation. In integral calculus, we will find the area. Very important thing, please keep in mind. In integral calculus, we will find the area. Find the area. 1 minute. We will find the area. Area. Let us take an example. There is a graph. I think 1 minute. 1 minute. We will draw again. There's a graph like this. And this is x-axis, this is y-axis, this is origin. Let me take it as velocity time graph. Velocity time graph. Now, what I am going to do is, I am asking you to find the area between these two time intervals. That means I mark these two places now. These marked two places, you should find the area between these two time intervals. Between these two particular time, I am asking you to find the area. How you will find this? Now let us first draw the slope. This is the slope. This is how the slope looks. Now I am asking you to find the area between these two time intervals. How you will find? You will find by like this. Between these two time intervals, you are going to find the area. The area will be this. This will be the area. This will be the area. Okay. Now what I did is, I just drawn a slope. I am asking you to find the area between these two time intervals. I marked now the 2 points. These 2 points, these two time intervals, these two particular times, you need to find. Between these two particular times, you need to find the area. This area means, in velocity time graph, the area we are going to find will give us the displacement. The most important thing is, in velocity time graph, when finding area, will give us the displacement. So, this area will give us the displacement. Now, how we will find this area? As usual, all know this shape, this area. Let us take this point as A, B, C. Okay? No, we don't need to find the name it and all. Now, let us take that. We need to find the area. You know that this shape looks like a rectangle. This shape looks like a rectangle. If it looks like a rectangle means, we can use the area of rectangle formula. What is the area of rectangle? That is length into breadth. Length into breadth only the area of the rectangle formula. Now, let me say that I will take time downwards. Now, let me say that from the origin to the starting time, origin to this, take it as from the origin to this point, we can take it as A. And I will take a drop this T, and from origin to this next, the second time interval, from the origin to the second time, it is B. Let us take it as B. From origin to this first time interval, it is A. This is A, and from origin to this second time interval, this is B. Now, what will be the breadth of this rectangle? That will be B minus A. How it will be? B minus 1 minute. B minus A will be the breadth. Yeah, as usual all know, this total length from the origin to the second time interval it is B, and from the origin to the first time it is A. So what will be this length? What will be this breadth? This will be B minus A. I don't like that. Now the breadth is B minus A. Now I am saying that up to this, let us take the height as C. In the y coordinate I am marking it is C, this height. That means the length is C. Now we have found that the length and the breadth. Using the formula, the area will be equal to C into B minus A. Using the area of rectangle formula, what is the area of rectangle? It is length into breadth. When use that, we will get it as area is equal to C into B minus A. Now we have got it. But here we does not use any calculation. We does not use this integral calculus itself in this situation. We does not use it in this situation. But we are going to use integral calculus in the second case. I am going to sell this in the second situation. Only we are going to find this different integral calculus. We are going to use that. Now as usual for this, what will be the area of this path? It is A is equal to C into B minus A. This C into B minus A will give the displacement between these two time intervals. Okay. So A is equal to C into B minus A. We found that more easily. Now let us take another graph. Let us take, I will rub this. Please remember we have found the area. I rubbed. Now let us take another case. 1 minute. One minute. Okay. Now I have drawn it. Let us take that this is x-axis and this is y-axis. Now the slope, that let us also take it as velocity time graph. But we don't need to represent as velocity time graph and all, because in integral calculus we does not need to consider this. We are going to only consider the summation in that. Okay, I will draw this. So the slope is like this. This is how the slope looks. Now what I am going to say is, let us take this point as A and let us take this point as B. This point as B. Now I am asking to find the area between these two points. That means the area between these 2 points. That is, how you will find is 1 minute. Sorry, 1 minute. The area between these 2 points. This is how you will draw and you will find the area. But in this situation, can you able to find the area more easily? The answer by you will be definitely not. Because in this situation, we can't able to find the area more easily. Why we can't find? Because the shape is irregular. But in first case, the shapes look like a rectangle. Rectangle means it is regular shape. But this shape looks like a irregular shape. That means it's not like a type of shape. We can't able to name that shape. That's only called as an irregular. So what we can say is, integral calculus means find the area of a irregular shape. That is very important thing. Now as I told, between A and B point we need to find the area. Here you can't able to easily find, as I already told that you can't able to easily find because it is an irregular shape. Now what I am going to do is, I am going to divide this 2 point, that means divide this the space into small strips. I am going to divide this shape, that means AB now, I am drawn a straight line now. I am going to divide this shape into small strips. Okay. Like this I will be dividing. Now I divided. This is how I am going to divide it into small strips. Why I am dividing? Because as I told earlier, it is irregular shape. When we divide means it somewhat becomes a rectangle na. So I am dividing, because if it become rectangle only we can use the length into breadth formula and find the area. But if it is in the irregular mean we can't find. So only I am dividing into strip into small strips. Now let us take this the number of strips as n strips. Now an important thing is I am going to make the strips as rectangle. You can see that here also the each strips is not a rectangle. You can see that here also the each strips is not a rectangle, because we can see that there's some curve. There's some curve here. So please understand that here we are not having a rectangle shape. The strips are not in the rectangle shape. Now let me say that the breadth of each strips is delta x. I am not saying for the group of strips. Only for the each strip the breadth will be delta x. The breadth is delta x for the each strips. That means for this delta x, for this delta x, for this delta x, for this delta x, and for this delta x. So for each strips, this length, that means this breadth will be delta x. Now I told. Now as I told, I need to make the strips as a rectangle shape. That is very important. How I am going to make is, see, you can see that now I made the shape into rectangle. How I made? How I made is, now I marked to make this rectangle. I leaved this space. Now I can able to make a rectangle. Now you can see that this is a shape. This is a rectangle, and this is a rectangle. 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 These are the shapes that I got now. Okay. If I made into a regular shape, that means a rectangle. Now I made that. Now what I am going to say is, you know that the breadth of each these small strips is delta x. Now up to A, 1 minute, up to A, the x coordinate, that means the x value will be f of A. Let us take it like that. F of A, up to A, the value is f of A. And up to this, 1 minute, I will draw A here. This is the point A, this is the point A. And from this point, from the origin to this point, let us take it as f of x. F of x. What I am saying is a simple thing. I just said that the breadth is delta x, and now I am going to say that length of the each strip. That means for the first strip, it is length is f of a. For the second strip, that's not this second strip, this length is f of x. And for the third strip, this is third strip now. Please understand, many people have confusion in that. We need to make it easier. Please understand slowly. Now the length is f of a, and the second strip length is f of x, and the third strip length is f of x1. Let us take it as like that. F of x1. This is f of x1. This third strip length is f of 1 minute. x1, like that I took f of x1. Next, for the fourth strip, the length how it will be? F of x2. And for the fifth strip, how it will be? F of x3. And for the fifth strip, it will be f of x3, as I told na. If we count it, it will be like that. What I did is, the length of this up to a, the first strip is f of a, length of second strip is f of x, and length of third strip is f of x, and length of fourth strip will be f of x2, and the length of the fifth strip will be f of x3. Like that, remember. Like that, remember. Now you can able to easily find the area. How we will find? The area will be equal to, how we will find is length into breadth. The length for the first strip is f of a and the breadth is also delta x, because for every strip the breadth I told is delta x da. So f of a into delta x. First f of a into delta x and plus the what is the length of a second strip? It is f of x. F of x into delta x, because for every strip the breadth is delta x into delta x plus f of x1, because for the third strip what is the length? It is f of x1. What is the breadth? As I told, it is delta x. And for the fourth strip, how it will be? For the fourth strip it will be f of for the first strip it is f of a into delta x. First strip area, second strip area is f of x into delta x, third strip area is f of x1 into delta x, and the fourth strip will be this one. I think this is the fourth strip now. That will be f of x2 into delta x. Okay, f of x2 into delta x. Like this is go on. Like this it will be going on. Okay, like this it will be going on. Please understand. These are the heights. Please understand very important thing. F of a, f of x, f of x1 are the heights of this. Each strip. So what is the how we will find the area? That is length into breadth. So for the first strip area will be f of a of delta x. For the second strip f of x plus delta x. And for the third strip the height is f of x1. Sorry, the length is f of x1. F of x1 is delta x. Fourth strip f of x2 into delta x. This is how we will find. You will find it goes on like that. So the n number of elements it will be going on, because that's n number of elements, n number of strips. Up to n number of strips it will be going on. Now what I am going to do is we are unable to write this more easily, because we should write f of x3 into delta x, f of x4 into delta x. We should continue. For that we can use the summation. Summation means what? Use the sigma symbol. That is, area will be equal to summation. One minute. Summation of the first part to the n number of elements of f of x, ith part into delta x. This is how it will be. What I did is, it is difficult to write more and more. So only I will contract into a simple form. When I contract means how it will be? Area is equal to the summation of first part to the nth number of parts of f of x ith part into delta x. Okay, please understand, this is a very important formula. So A is equal to the summation of, okay. Now understand this area cannot be an accurate area for the total. Why it cannot be accurate area? Why? That means this summation of first part of the n number of strips into f of x ith part into delta x. This cannot be an accurate area. Why? Please remember, we just found the area for the rectangle only and just we added. But we missed this triangle now. We missed the small triangles located on the top of this rectangle. We missed these triangles. If we mixed these means, we are going to. If we mixed means, definitely this will not be an accurate area. That means the total area will be added to the triangle now. But we don't know how to do that. We just found the rectangles and added all the areas of rectangle. That is f of a into delta x, area of first strip, area of second strip, area of third strip, area of fourth strip. Like that, added and simple into this form. But this cannot be accurate area, as I told, because we does not add the small triangles located on top of the rectangle. That's a small triangle, na? We does not add this. So what I am going to do is a very important thing. Please listen carefully. You know that each strip looks like this. 1 minute. Each strip looks like this. Each strip looks like this. And we know that the breadth of each strip is delta x. Now very important thing in integral calculus is now only a very important thing. That is, we are going to, this is a triangle now. We are going to reduce this triangle. How we are going to reduce? By increasing the n number of strips. When we increase the n number of strips, definitely we can able to find the accurate area. Many people don't understand this. I will tell it again. Please listen carefully. That is, we know that this breadth is delta x. Now we does not add this triangle area, na? We does not add this triangle area. But now, how to find the accurate area? We are going to take out this triangle. We are going to decrease this triangle. How we are going to decrease is, we need to increase the number of strips. That is, the number of strips is n number of strips, only the number of strips. N number of strips. That means n number of elements. These strips are called as elements also. So n number of elements. We need to increase this n number of elements. That means, when we increase the element means, the elements will become smaller like this. It will be smaller like this. Like it will be smaller. To understand more easily, because these are the elements, these are strips. When we want to, again I will draw, because some people always be confused in this. So, this is how it looks. This is a triangle, this is delta x. Now, as I told, we need to increase this n number of elements. When we increase means, we are going to increase the strips. We are not going to increase these strips, this accurate length. We are not going to increase this strip. We are going to increase. Increase means like this. The each strip will become as like this. When it will become like this, because when we increase means in this small area, when we want to increase the strips means like this, it will become like this. It will be increasing, because in this part it will be increasing. On this time, you can see that on the first time, I will again draw. On the first time, you can see that this triangle is cancelled out in now. When I draw, when I increase the number of strips, n number of strips only there, no. So n number of strips increased means we can able to reduce this triangle. That is more and more an important thing in integral calculus. That is, when we increase the n number of elements, when we increase it means definitely we are going to decrease this triangle, because there is a triangle now. We are going to decrease when we increase the number of strips. N only the number of strips. So when we increase means it will become like this. Okay. I will again draw. Please understand. 1 minute. When we increase means it will become like this. So what I am going to say is very important thing. We are going to increase n number of strips. Then only we are going to minimize the triangle. That means this triangle. So how that means, when the n tends to infinity. What is this infinity? As I earlier told that when we are increasing this n number of elements, increasing means we are going to extend. We are going to increase means we are going to tell it as n tends to infinity. What? Infinity. We are going to n tends to infinity. We are going to increase that. The n tends to infinity means we can tell it as, because we are increasing the n number of elements now, so it will be n tends to infinity. When this n tends to infinity, a very important thing is there. A very important thing. This is strip now. When we increase this infinity, n tends to, when we increase the n number of elements, become like this, and the triangle become minimizing. The triangle is minimizing. But You can also understand this. This delta x will also decrease. Yeah, when we increase the number of elements means this delta x is going to decrease. The very important thing is this delta x is also going to decrease when we increase the number of elements. So when n tends to infinity, surely the delta x will tends to 0. Many people somewhat difficult to understand. Basically, when I started to read, I also felt difficult. But when you step by step watch the video again and again, we read the book again and again, then only you can able to understand. That means when the n tends to infinity, when you increase number of steps, it will be like this, it will be increasing. And also this total length is delta x. It becomes like this, it becoming small now. When delta x, when the n tends to infinity, the delta x becoming small because the line is become like this now. When the strips are increasing like this, it will be dividing. When it divide means this delta x should be smaller and smaller and smaller, and that smaller is called as delta x tends to 0. Now you understand this means, then we can easily derive the integral calculus. That is when the limit of where I can draw 1 minute, I will write this on this side, okay, 1 minute. When the n tends to infinity, sorry, 1 minute. When the n tends to infinity, surely this delta x, that means the breadth, will also tends to 0. A very important thing. So that what we can say is area is equal to 1 minute. Area is equal to I think limit of, we are not going to write it as n tends to infinity. We are going to write as delta x tends to 0 because we are having the delta x in the function. After function we are having delta x only. So we are not going to n tends to infinity. If n tends to infinity only, the delta x will also tends to 0. So limit of, when n tends to infinity, delta x is going to tend to 0. So I am writing like the delta x tends to 0 of summation. 1 minute. Summation of first part to the nth number of part of f of x, ith part to the delta x. Now I am going to rearrange it because this limit of delta x tends to 0 is very important. Then only we can minimize this triangle, because earlier when n times the number of strips increase means the delta x will turns to 0. So what will happen is like this, it will be becoming. So the new value that we get is when the limit of delta x tends to 0, the limit of delta x tends to 0 can also be written as dx na. When the limit of delta x 0 of summation of first part to the nth part f of x delta x. Here only we are going to represent that integral symbol. Integral means this is the symbol of integral. Please know this is symbol of the integration is this. So that means integration of that same f of x. F of x. But when the delta x tends to 0, in differential calculus you have learned now, when delta x tends to 0, it becomes as, the delta x becomes as dx. The delta x becomes as dx. So integration, this symbol is very important. This is called as integration. Integration of f of x dx. Because please understand this, we don't need to ask the reasons and all. We should be this is like a definite rule. It will be changed into integration of f of x dx. Then limit of delta x tends to 0 of summation of ith particle to the first part to the nth part f of x may be written as integration. We can change it in integration because that's a limit. Integration of f of x, same f of x, but this delta x tends to 0. We are having one term, this is very important. This delta x tends to 0 means it becomes as dx. Now in differential calculus we have learned that. So dx. Now this is called as an integral calculus. For then this f of x dx will give this area for this strips. The total area of this curve will be this f of x dx. This f of x dx will be giving as the area. If you understand these things itself, then differential calculus, sorry, not differential calculus, integral calculus will be like, you can able to understand this integral calculus. Integration of f of x dx. If we, as I told many things, if you understand step by step means definitely you can able to understand. This integration of f of x dx will give us this area, the area of this curve. Now I will rub this. Now I will tell some of the formulas. 1 minute. I am going to rub all things because I am going to tell the formulas now. The formulas. Formulas. What are the formulas we are having? The most important formula is integrating x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1 plus a constant c. This is very and very important formula because in application of derivative we will solve in most problems in this. Please remember this formula. Integration of x to the power of n is equal to dx, integration of x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1 plus constant c. And integration of dx is equal to x. Integration of dx is equal to x. And these are the basic formulas that you need for the physics. These formulas, if you remember, means for the physics it's essential. For physics it will be essential, but for mathematics you need to know all the things. But integration of trigonometric function only you need to know. But soon after this integration of f of x dx may be written as using the limits also, upper limit, lower limit. We can also write it like that. But we does not start our definite integration now. When we study only we can able to represent. But until then, please remember this integration of f of x dx. This is only called as integral calculus. Some formulas: integration of x to the power of n is equal to x to the power of dx is equal to x to the power of n plus 1 divided by n plus 1 plus constant c. And integration of dx is equal to x plus c plus constant c also important. These are some basic formulas. Please remember these formulas. In integral calculus, you need to remember these formulas only. As I told, this integration of f of x dx will give us the area. Okay. I think this integral calculus will be easier now. Please remember these formulas will be easier now. Definitely integral calculus is an easy topic when you understand the basic. As I told, no, even I taught it as. I thought this chapter as difficult, but when I studied mainly, the chapter will become easier. And repeatedly watch this video and repeatedly read the book, then you can easily understand. Okay, a good chapter this is. Now I think the integral calculus will be easier. Okay, if you have any doubts means please comment me. Thank you. Make education simple.